Good day, everyone. Today we're going to discuss how to solve word problems that involves quadratic equations, or what we call the applications of quadratic equations. Let's start with problem number 1. Difference between a number and its positive square root is 12. Find the number. Okay, of course, we're going to start with this. Let x be the required number. Okay. Let x be the required number, and then from the equation it says here difference between a number, okay, this number minus its positive square root is equal to 12. So this is how we represent the equation for problem number 1. X minus square root of x equals 12. Then we're going to transpose 12 here, becomes x minus 12. We're going to transpose negative x, square root of x becomes positive square root of x. Now, let us square both sides of the equation. X minus 12, quantity squared, square root of x squared. Then what is x minus 12 squared? We have x squared minus 24x plus 144 is equal to x. Okay. Then x squared minus 24x minus x is minus 25x. So as you can see, this equation, x minus square root of x equals 12, was transformed into a quadratic equation. X squared minus 25x plus 144 equals 0, which can be solved by factoring. What are the factors of 144, whose sum is negative 25? These are negative 9 and negative 16. So that if we equate x minus 9 and x minus 16 both equal to 0, then the values of x are positive 9 and positive 16. Okay, so let's check for 9. I have, so this is now the checking part. 9 minus square root of 9 is equal to 12. We have 9 minus 3 equals 12. 6 is not equal to 12. So 9 is not the solution. 9 is not the required number. How about for 16? 16 minus square root of 16 is it equal to 12? 16 minus 4 equals 12. 12 equals 12. So right, correct. So 16 is the required number. Yeah. 16 is the required number for problem number 1. Let's proceed to number 2. For number 2 problem, we have here a piece of iron rod costs $60. If the rod was 2 meters shorter and each meter costs $1 more, the cost would remain unchanged. What is the length of the rod? Okay, let's first represent x as the length of the given rod. And let x be the length of the given rod. Then the length of the length of the rod 2 meters shorter is x minus 2. 2 meters shorter. This is the length of the rod, which is 2 meters shorter, and the total cost of both the rods is $60 because cost would remain unchanged. So the cost of 1 meter of the given rod is 60 over x. This is the cost of 1 meter of the given rod. Cost of 1 meter of the given rod, while the cost of the 1 meter of the rod, which is 2 meters shorter, is 60 all over x minus 2. Cos of the rod which is 2 meters shorter. Cos of the rod which is 2 meters shorter. Yeah. So if the rod was 2 meters shorter and each meter costs $1 more, that is 60. This will be our equation now. 60 all over x minus 2 minus 60 all over x is equal to 1. Right? So this will be our equation because if the rod was 2 meters shorter and each meter costs $1 more, then we're going to subtract the cost of the rod 2 meters shorter with the cost of the rod 1 meter, which is equivalent to $1. So from this equation, let us now solve for x. Right? How? So we have here 60x minus 60 times x minus 2, 60x plus 120 is equal to x times x minus 2. Right? 60 times x, 60x minus 60 times x minus 2, 60x plus 120. And then, yung 1, multiply natin dito sa product of x and x minus 2. Okay. So, from here, cancel na yan. Then, we have x squared minus 2x minus 120 equals 0. So, that is now the quadratic equation that we're going to solve. X squared minus 2x minus 20 wait. X squared minus 2x, yes, minus 120 equals 0. So that from here we can now solve for x. What is the value of x? So let us now factor. What are the factors of negative 20 whose sum is negative 2? I think it's 10 and 12. Since negative yan, this will be negative, this is positive. So that negative 12 plus 10 is positive. Yes, negative 2. So solving for x on this part, x equals negative 10 and x equals positive 12. So we will not accept or we will ignore the negative answer because there's no negative length. So therefore the length of the given rod is 12 meters. Okay. So what is the length of the rod? The final answer is 12 meters. So that is how we answer problem number 2. Let's proceed to number 3. For problem number 3, we have here divide 25 into 2 parts so that sum of the reciprocals is 1/6. So let x be one of the parts of 25. Okay, let x be one of the parts of 25. Then the other part is 25 minus x. The other part. X, one of the parts of 25. 25 minus x, the other part. And the sum of the reciprocals is 1/6. So what is now the sum? What is the reciprocal of x? 1/x. And what is the reciprocal of 25 minus x? We have 1/25 minus x. And their sum is 1/6. So this will be our equation to solve problem number 3. This is a rational equation that can be transformed to quadratic equations. So let's start. You can add this part. Okay, you can add this first, the left side of the equation first. 1 times 25 minus x, 25 minus x, plus 1 times x is x, all over the product of 25 minus x and x, we have 25x minus x squared. Is equal to 1 over 6. Then we can cross multiply. What is 25? Wait, we can cancel this out now. 25 times 6. What is 25 times 6? It's equivalent to 150 and equal to 25x minus x squared. You can transpose this. X squared minus 25x plus 150 is equal to 0. So as you can see, this rational equation was transformed into quadratic equation, x squared minus 25x plus 150, which we can now solve for by by factoring. For the factors of 150, whose sum is negative 25, we have negative 15 and negative 10. So therefore, what are the values of x here? This part, 15 and or 15 or 10. Okay, positive 15 or 10. So, if one of the parts is 15, and what is the other part? So when x is 15, here, when x is 15, the other part is 25 minus x, 25 minus 15 is 10. So the other part is 10. And if x is equal to 10, what is the other part? 25 minus 10 is 15. So therefore the two parts are 10 and 15. Okay, these are the two parts. So that the sum of this, the reciprocal of these two, is equal to 1 over 6. And for problem 3, let's proceed to problem number 4. For problem number 4, we have here the hypotenuse of a right-angled triangle is 20 cm. The difference between its other two sides is 4 cm. Find the length of the two sides. Okay, first, let us have here x and x plus 4 as the length of the other two sides. Length of the other two sides, because it says here the difference between its other sides is 4 cm. So x and x plus 4. So that means these are the lengths of the legs of the right triangle, while the length of the hypotenuse is 20 cm. So using Pythagorean theorem, we have x squared plus x plus 4 squared is equal to 20 squared. Right? The sum of the squares of the legs is equal to the square of the hypotenuse. So let's have here x squared plus x plus 4 quantity squared is x squared plus 8x plus 16. It's equal to 20 times 20 is 400. X squared plus x squared is 2x squared plus 8x 16. 16 minus 400 is negative 384. Let's just simplify this quadratic equation. X squared plus 4x minus 192 is equal to 0. Right? So you can now solve this by factoring, or you can solve this by completing, whatever you like. So what are the factors of negative 192 whose sum is 4, positive 4? I think these are 16 and negative 12. 16 times negative 12 is negative 192. 16 plus negative 12 is positive 4. So the values of x are 16 and positive 12. Okay. So again, we cannot accept negative 16 as a length because we do not have a negative length for the legs of the right triangle, so that we only accept the positive 1, which is 12. So find the lengths of the sides. So we have 12. What is the next side? 12. Okay, the other side is x plus 4. 12 plus 4 is 16. And of course, the hypotenuse, 20 cm. So these are the sides of the right triangle. 12 cm, 16 cm, and 20 centimeter. Okay, let's proceed to number 5.